Alright, it's Mr. Fry back from his living room for example 2. But first let me show you what factoring cubes are. Cubes are different because they follow a pattern. So let's take a look at the two patterns I wrote up here for you on the board. The first one right here is a cubed plus b cubed. That's a sum of two cubes. And then there's the difference one. I'm going to try to show you both of them, so bear with me. Alright, so check this out. The first one is a plus b, and then we broke it down to a pattern of a squared minus a times b plus b squared. So the sum of two cubes, it looks like this. Now here's a problem you'll see on your pre-task, 8x cubed plus 27. Well, the first term right here can be broken down further by pulling out everything that creates this. And same thing with 27. If you look at the first a term, a little ax cubed, 8 can be broken down to, well, how does 8, the cubic root of 8? Well, it's 2 times 2 times 2, which makes 8, so we can pull that out. And then the x obviously is there 3 times as well, so we know that the first term is cubed. The second one is cubed too. Even though that 27 doesn't look like there's a cube there, it is. What is the cubic root, not square root, but the cubic root of 27? Well, broken down, it's 3 times 3 times 3, which is 27. So yes, we're dealing with two sums of two cubes. So let me clean this up a little bit so we can see the a and the b more clearly. We have 8x cubed plus 27, which is really, isn't it really 2x's cubed? And then the second part isn't really 3 times. So I've simplified the a and the b, and I broke it down in my head by thinking about how the cubes are formed. Now I need to go ahead and follow the pattern that I gave you. I got to break this a and this b, and then follow the pattern. So here we go. Hope I don't lose you. The first one, the a is 2x, and the b is 3. So I put those in parentheses because it follows that pattern. I'm not thinking, I'm just following the pattern. And the second one is going to be 4x squared, because that's a squared. A squared is 2x, so square that thing would be 4x squared. A and b, so minus a and b, which would be 6x, right? Because 2x times 3 would be 6x. And notice I put a minus sign to follow the pattern. And then the last one would be b squared. Well, b is 3, so 3 squared is going to be 9. And that, my friends, is factoring two sums that are cubed. Notice how I found the a and the b that were hidden in the original problem, and that's the hardest part. Alright, let's take a look at another example for the difference of two cubes. I have a cubed minus b cubed, and it's going to follow the same pattern, so it makes more sense when I give you an example. I have 64x cubed minus 1. Alright, so sorry about my handwriting, but that's a normal 64. That's not some weird notation. That's just me writing some stuff down. Alright, let's go ahead and break that down. Well, 64x cubed, cubic root of 64 is, well, 4 times 4 is 16 times another 4, that's 64. So definitely going to pull out that 4 and that x and make that guy cubed. So I found my a. Now I got to find my b. Well, that's easy. 1 times 1 times 1. Well, guess what? I'm going to put that 1 in the cube action there. Now I have my a, which is 4x, and I found my b, which is 1. Sometimes I like to do this too on the side. I didn't do in the first example. I just write my 4x like this, and then my b would be 1. Alright, so let's go ahead and follow that pattern. We have a, which is 4x minus 1. Now I need to follow the pattern of a squared plus b plus ab plus b squared. So 4 times 4 squared. Let's see here, 4x, it would be 16x squared, if I multiply that itself. And then plus ab, which would be 4x. And then we need to find another plus, which would be b squared, which is simply b1, because 1 times 1 is 1. And there, my friends, I have now found the difference of two cubes. The hard part, again, is finding that a and that b. All right, I hope this helps. I'm going to give you 2 more examples, guys, for Algebra 2, so stay tuned.